Hello, protocols, packets, and programs. Welcome to October, when tales of terror become timely and horror marks our days to Halloween. Gather your scary stories and prepare to tell some spooky tales. And if you need inspiration or are looking for a ghostly visitation, just peruse some code comments for to-dos or similar notation. Search for patterns like hard-coded cryptographic material, because even well-tended repos have corners funereal. Which means, this week we chat with Huxley Barbee about OT devices, their dusty past from the last 30 years, and what security for them might look like for the next 30 years. In the news segment, HTTP 2 rapidly resets, curl patches for proxies, OWASP campaigns for Cyclone DX, Microsoft cleans out some cobwebs, and more. Read some code, and stay tuned for Application Security Weekly.
This is Security Weekly, for security professionals, by security professionals.
It's the show to learn the latest tools and techniques to understand DevOps, applications, and the cloud. Your trusted source for the latest Appsec news. It's time for Application Security Weekly. AI, accelerated cloud adoption, and hybrid work are fundamentally shifting how business gets done. The old way of securing your people, apps, and data doesn't work and scale anymore. To stay ahead, today's organizations need to reimagine their security and networking infrastructure with a cloud-first, unified SASE architecture. Join Palo Alto Networks and leading technologists from across the globe for SASE Converge 2023, a two-day virtual experience, November 15th through 16th, revealing how SASE, powered by advanced AI, can drive better security and networking outcomes. Register today at securityweekly.com/Palo Alto. This is episode 259, recorded October 16th, 2023. I'm your host, Mike Shima, and I'm here with John Kinsella. Hello, John.
I've got two questions for you on this Monday morning. Well, two to say when our listeners listen to this. One, how many punch cards does it take to record an episode of ASW? Two, how many punch cards does it take to watch an episode of ASW? A little bit of foreshadowing.
A little bit of foreshadowing, and it's going to take more fingers than I've got on my hands to answer that, so let's see what happens. But speaking of numbers, John, we are celebrating the milestone of reaching over 1,000 members of our CISO community. The Cybersecurity Collaboration Forum is a one-stop shop for executive collaboration comprised of CISOs across various industries. If you want to be part of this growing community of CISOs, join us as a member or technology partner. To learn more, visit securityweekly.com/cybersecurity collaboration. Huxley Barbee is the organizer for BSidesNYC and security evangelist at runZero. Huxley previously worked at Datadog, where he formulated their cloud security platform. Earlier at Cisco, he led a team that automated SecOps and IR playbooks. He holds both the CISSP and CISM certifications. Hello, Huxley. Thank you for joining us.
Thank you for having me.
We're having you here because hopefully that intro didn't feel like it was too long in your aging, because we're going to be talking about some aging devices, some OT, and you've actually been speaking on this a couple times in the past year. So operational technology is about the limit of what I know about the acronym. So maybe introduce us a little bit to maybe what, and perhaps more fun, where people would find OT systems.
Yeah, so there's a lot of variety in OT, right? On the IT side, we basically have really stock machines like PCs and Macs that can be used for a variety of tasks. You could do financial modeling, but you could also stream movies, right? So lots of different tasks with very few types of devices. But on the OT side, you have a huge variety of devices simply because they tend to be built for one single specific purpose. And the types of environments we're talking about oftentimes are what CISO considers critical infrastructure and key resources, right? So our dams, our utilities, our factories, which includes like pharmaceuticals as well as like cars, right? But OT can go beyond critical infrastructure and key resources to include buildings, like building automation. That's considered OT as well. So for those who want like a very quick rule of thumb, here's one little thing that I like to ask in order to help people understand, like, is this OT or is this not OT? And it's not always 100% true, but just think this. If I walk into that environment, do I need to wear a hard hat? Yes or no, right? It's not 100% true, but oftentimes you're going to be right. Yeah, so that would say, that's what I would say about OT.
I'm thinking of 30 years ago of OT is also when Jurassic Park came out, which I think is also a lesson in some OT devices and availability. So I'm curious, if we look at the history of OT, not stellar in terms of security. So maybe give us a little hint of just what those problems are. And I think the follow-up question is going to be, have we learned anything from them? So maybe just a quick trip to the past first.
Yeah. So the thing about OT is most of us don't even really realize what they are, because, when you're just getting started in security, you're in your dorm and you could play with like the IT side, because you could stand up a computer and run Kali Linux or whatever. But most people don't have the opportunity to run a PLC in their own dorm room. So we don't always have an understanding what that is. And the fact of the matter is, it's very, very different. OT devices tend to not have the operating systems that we're familiar with. The time-sharing operating systems like Linux and Windows and so on and so forth, they tend to have real-time operating systems. And there's like not just 3 of them. There's like over 60 of them just on the Wikipedia page for it. For example, they tend to not have the programming languages that we're familiar with, like in Linux, like Python and Java and so on and so forth, but programming languages that we've not typically heard of, like ladder diagram. But I think more importantly is the security concerns around those OT devices. The organizations that own those devices, that operate those devices, they care about availability much more so than confidentiality and integrity. And so for that reason, all the security concerns and all the security programs around those OT devices sort of orbit around that availability concern. Whatever they do, they want to make sure that those devices don't go down, because they might be endangering people's lives, the water supply, the gas supply, and so on and so forth. And so oftentimes confidentiality, integrity take a back step to it. And it also means that security governance that you would normally see on the IT side also takes a back step.
Yeah, I want to come back to the governance part, but it's funny, and I know exactly what you mean about availability being so important, but notoriously, you could run, in the old school days, you could run an Nmap against these, a port scanner, and a lot of their TCP IP stacks would be brittle, which suddenly now is a loss of availability. So I'm curious, have you seen, either aspects of those, just what makes those TCP IP stacks perhaps more brittle, because they're being scanned, or, what, I know we can't mind read here, but sort of that focus on availability, how that came at the expense that was being tested about normal circumstances, I think is what I'm going for here, rather than the abnormal circumstances or misuse or abuse that security testers are going to bring into the conversation.
Yeah. So, if we look at the popular operating systems on the IT side, Linux, Windows, Mac, their network stacks have been thoroughly tested, not just by QA engineers, but just the world. Right? So very well tested, very robust. Now, on the OT side, remember, these devices are all very specialized. There's a lot of variety in them. There are thousands of different types of OT devices at the very least. And they have network stacks that are not as well used. And when they're QA'd in such a way that to make sure that they respond to the push of a button or the flip of a switch, not being QA'd against arbitrary network traffic. So that's one class of network stack, the one that are not popular. And then, of course, we also have devices in OT that have been around for 20, 30, in some cases even 50 years. So you're looking at network stacks that are very, very old. And it's not just the network stacks, but it's also the applications on top of them that are either not well tested, not well tested for robustness, or they're very old. And for this reason, many of the common techniques that both offensive and defensive security professionals would use to enumerate devices on the network tend to go badly, right? Because the tools that we use, oftentimes will send different unusual types of packets in order to elicit a certain response from that device in order to fingerprint it, right? This is very common with TCP/IP stack fingerprinting. But because these devices are either have a really old network stack or a network stack that's not tested at large or at scale, they will be disrupted. They will be disrupted, and they're not able to perform the functions that they're supposed to. So they will freeze up, they will crash, or reboot. All of which are absolutely horrible in the case where availability is so important, right? Where you want to avoid any outage at any cost. That sort of active scanning that you might do is just not going to work. Now, with that being said, some of the devices that have been developed and released in, let's say, the last 5 to 7 years, they seem to do okay with active scanning, but that is not the majority of OT devices out in the world. Most of them are at least as old as I am, if not older. And so that's a huge issue. And for this reason, a lot of defenders will use passive techniques for understanding what's on the network.
So I guess part of what I'm trying to wrap my head around here, even how to phrase the question, but if we're dealing with technology which is so old, should we be approaching the application security of that overall stack in a different manner? In other words, like, if I'm worrying about, a ping of death or, Modbus or these other CAN bus or some other sort of attack, if I'm worrying about something down at like level 2 or 3, should I even be caring about, obviously caring, but should I be giving as much thought about SQL injection or other type of higher level, say layer 6 or layer 7 type attacks? Is that even like crossing my mind when I'm working on these type of things or securing them?
I wish it would. I mean, because when we think about security, we should be thinking about the entire stack, right? All the way at the top with application security and further down with network security. Absolutely. Are these the worst problems? Well, it depends, right? If this is a device that for some reason is directly connected to the internet when it shouldn't be, then those application security concerns like SQL injection are going to raise to the fore, right? So there's the importance of something like a SQL injection attack. It varies based on context, network context, and so on and so forth. But yeah, I mean, if you are developing a device, I sure hope that you are applying a full, SDLC to the development of that application, please. Right? And even if you don't have, a SQL database on the back end there, like, still be doing like the same types of things that you would do to prevent SQL injection attack. Just input checking at the very least, and because all these devices are executing something on the command line, I'm sure.
On that testing aspect, in fact, there's both just to do, the developer side testing and QA. Is the stack robust for one, as well as just does it meet the requirements that were designed for it? But also security testers, how easy, accessible is it to even play with these? You mean in the sense of, can I drop an OT device into a VM? Everything runs in Docker these days. Can I containerize these somehow? I'm pretty sure the answer is no, but it's more about how does someone go about even just playing around with these and testing them, just to understand what their basic functionality in the first place. That
is definitely more difficult. The thing of it is, like, many of these devices are proprietary. And so if it is a company where they're actually developing it, presumably they have some sort of containerization or virtualization capability to do that. This is definitely a newer thing for those types of organizations, obviously. So it should be possible, but I've not seen confirmation that that's actually happening. Could be, but I don't know for sure.
I think one of the things too, and this is touching some areas that I'm less familiar with, but for example, running the Raspberry Pis. So can you also either emulate or run these OT environments on a Pi as well, and get some similar behavior with the understanding that you're not connected necessarily to the physical devices that they may be controlling, whether it's as simple as a elevator, something a bit more complex like water salinization, things like that. But I'm curious, has there even been any modern movements that would even make this type of testing a bit easier, or some uniformity or commodification in this area?
So where I've seen Raspberry Pis is more on the IoT side, and it could go into an OT environment as, quote unquote, like industrial IoT, but nothing's going to replace that sort of hands-on testing with an actual PLC, right? And those are the types of devices that are hard to get your hands on for testing purposes.
And so what would be what might some of that testing be like in the sense of, maybe it's just that brittle network stack, so it's going to fall over from an Nmap scan or something like that. But are there we hear common flaws of like default passwords? Are these 30-year-old types of flaws still out there in possibly the 30-year-old types of devices, but even the new devices that are being created with, CISA has guidance, the UK is coming out with some standardization with some requirements for these devices that they're not supposed to have default passwords, for example. How much of this have you seen affecting change versus we're just still seeing the same problems?
It's not just default passwords, it's default users, it's default configurations, and actively not patching or keeping up with updates and things like this. Because these organizations, they tend to value availability above all else, even if it means remaining insecure. And so they don't want to change things. Well, first of all, the person that deployed that device was probably more of a technician than a security engineer, right? So think about the person that installs your FiOS, for example. Like that person, will plug in some cables and make sure the device is working, and then they walk away to go to the next job. It's that type of thing. And so, for that reason, they tend to just start off with a lack of security governance. But then on top of that, the business side of these organizations tend to not want any change on those devices to make sure that they keep going, right? Things are changing, obviously, because there's more awareness of the problems that this would entail, right? Especially since, I'd say, around 2005 or so, when these OT environments, which previously were air-gapped, which made all these insecurities okay. It was okay to not have authentication. It was okay to not encrypt your traffic, because in order to compromise the device, you actually had to walk up to it, right? Or somehow get a thumb drive over to it. But as these OT networks have been overlaid on top of IP networks and accessible to the internet, there's been more awareness that, hey, we really need to do the proper security governance here and lock these things down, keep them up to date, and make sure that they're remediated from a security perspective. That is happening more. But as we oftentimes hear from notable OT-related incidents, that it's definitely not happening as much as you would like. And I was recently speaking to somebody else who does security consulting to many OT organizations. And, from that conversation, it seemed clear that the infiltration of OT environments is probably much higher than the exploitation of OT environments. Because if you're a good adversary, you are going deep into the ICS network, ICS part of OT, and you're probably not doing anything nefarious. Not until you want to, right? But if you are a more casual adversary, you would probably just exfiltrate or ransom something from the IT side, rather than going, really deep on the OT side for that activity. And so,
yeah, that's a good point.
Things are much worse than we think, probably.
Yeah, that's a good point. That gives at least a different appreciation of what the threat scenarios and I imagine what the threat modeling weights, if you will, or concerns are different. Clearly, the availability, the dwell time, as you're hinting at, probably is on the order of years rather than even days or months in these systems, perhaps.
Yeah. And think about it this way. If you're going to ransom a dental office, probably going to ransom like 10, 20K. If you're going to ransom an electrical utility, it's going to be millions.
It's going to be a bit
right?
more.
So the effort and the type of adversary is going to be commensurate with the payout. And so they're going to spend more time and they're going to be way more careful. And so it's more than likely there's more infiltration than we realize.
Now, does that also give a chance, though, that defenders can be more creative, or defenders can use modern techniques, topologies, tools to defend and protect these 30-year-old, for example, devices. Meaning, I don't think they're running, they're not some XDR solution or anti-malware or antivirus on their OT devices, but maybe there's a shift to the network or monitoring that is helpful there, that's perhaps different from how they might approach something on the IT side.
In fact, some sort of network security control is probably the first step with securing OT environments, because these OT devices are so old, it's not like there's an EDR available that you're going to deploy on it, right? You just don't have that sort of like host level protection. And so oftentimes people will use some sort of network control like IPS or a firewall to put something in there. If you're not going to air gap, then at least have some sort of network control. But alongside of that, and this is probably a scary thing to say, is most security teams don't realize what OT devices they have, right? There just isn't an asset inventory for OT, so they don't even know what they're protecting. And that's part of what makes it really difficult, because coupled with this fact that typical enumeration tools for OT devices tends to crash them, you have the situation where either you need to use some sort of passive discovery capability to go figure out what's on the network, which has your mileage may vary because it has a lot of drawbacks, not always accurate, or you need to use a super modern active scanning capability that is purposely built to avoid crashing those types of devices. Ironic to say this, but to deal with a super old problem with these super old devices, you need to use much more modern tooling.
I'm curious about.
Speaking of modern tooling, I'm curious about on the programming language side of this, if that's modern or not. When I think PLC, I think ladder logic. I think just like very sort of, rigid designs, specifically sort of for its conversation, right? If you're using a language like that, it's harder to make mistakes. But from what you're seeing, is that how these are being used now? Are people using still 2GL, 3GLs on them, or are they using something more modern like a Node or a Java or Rust or?
Yeah, so for like the operations of the PLC, it's still going to be those bespoke OT languages for sure. Some of the more modern stuff that actually have web interfaces on them, I have to imagine some of them, at least they're using JavaScript for the client side, right? Or something along those lines, because you're not going to build a web interface with like something other than that, right? But the network stack is still going to be like whatever that came with that came from the vendor. So it's with the modern device, it's going to be more of a hodgepodge.
Now, along those lines, I've been a fan of like LLVM, for example, introducing for C and C++ like address sanitizer, a bunch of other just sanitizers, or even libfuzzer for that matter, to help do some security hardening, detect bugs that lead to security flaws at build time. Has the security ecosystem or the security of the build tool chain, to continue to throw out bingo words here, has that also been appreciably improving over the last years, or are a lot of these OT developers still relying on pretty old tool chains that haven't introduced modern things like even ASLR, for example?
Yeah, well, this is what you're saying is almost a call to action to many of these OT device vendors, right? Some of them obviously are adopting more modern techniques and tooling to help with that, but not necessarily all of them are. And there are so many of them is a thing. There are a handful of like really large OT device vendors, but the ecosystem is so large and varied that it's hard to say with any certainty that like the majority of them have adopted these newer techniques.
So, and is there, John, for example, just as you list a couple languages, Rust was one of them, and Rust is the fancy, a favorite du jour of, to use the French, just because the memory safety, and it can also run bare metal. Is this something that you've seen OT device makers at least consider or approach, or is that just something that it's not robust enough yet because it doesn't have availability guarantees because it's quote unquote still a new language?
I I'd say there's definitely a lot of inertia on the OT side. So I would be surprised to see like widespread adoption of Rust, for example. But surprising.
I guess in that aspect, looking. So we've been talking a lot about the OT devices, 30 years old. What about the next 30 years? Are there what should change in the governance? What should change in maybe even just the programming language or the tool chains or the designs or something, so that in 30 years from now we can look back and say, oh, it's good. OT devices really cared about availability and integrity. Maybe we're getting at least 2 out of 3, in priorities this time.
Sure. Definitely things are going to get better because, walking into OT security is like getting into the DeLorean with Marty McFly and going back 30 years. It really feels like that, right? 30 years ago, you had your PC tower, and so did everybody else. And you'd be hard pressed to find antivirus
Yes.
installed, right? Because nobody wanted it. Like, oh, it's slowing down my computer. But these days, everybody has EDR on their devices, right? It's just accepted that you have that. I imagine 30 years from now, it'll be similar with OT, where like security is very common, right? Where all the traffic is encrypted, where authentication is on by default, and things like this. Like that's going to happen. It might be on a longer time horizon, simply because some of these devices have a shelf life of like 50 years or something like that. So it may take longer, but the fact of the matter is these things are already changing, right? The whole idea of like OT environments being air gapped, and so therefore you don't need to worry about any other form of security. Like that's past history at this point, and we're not going back to disconnecting our OT networks from everything else. So like things have to change. So I expect things will get better over time. The adversary, of course, will evolve, but defense will also evolve to meet the challenge.
So what are some of those things? Do you have a short list of just 2 or 3 of those areas where you'd love to see priority of those changes? So, for example, just a network stack that is robust enough to be scanned, and just a polite scan doesn't knock it over. What are some other changes you'd love to see for these future devices?
And this doesn't apply just to OT, but just to like all compute devices in general. And I think this would help security teams tremendously. But the whole idea of fingerprinting, to my mind, is just like this black magic in security. Like only the esoteric few can figure things out. I mean, and it's just these devices oftentimes make it so hard to reveal who they are. And I realize in some cases that's because the way the device was built, but in some cases it's done intentionally to avoid enumeration by the adversary. But at the same time, it also makes defense harder. And, at the very least, you want to know what you're protecting. If you don't know that, then you're always going to be on the back foot. You're always going to run into an incident where, oh, hey, here's a device that was supposed to be decommissioned like 5 years ago. Or like, here's a device that I didn't even know we had. Like, that just puts defense on the back foot, and it doesn't actually help anyone to have that sort of obfuscated identity of those devices. So that's one thing that I would love to see change, right?
Yeah, it does seem like a terrible combination of that classic insecure configurations or insecure designs of OT with the classic problem of not even knowing what we have, asset inventory being an older problem. Mm-hmm. But John, I know you had another comment there too.
I was just thinking around that. I know we keep stepping in each other. Around the asset inventory for OT devices, you'd think that since these devices are controlling such larger scale, expensive projects, that people would have a better understanding, a better sort of idea of what actually is out there running their systems. But it seems like the exact opposite is happening, because you think use a metric like cost per device, or like what that device is actually supporting, not cost per, but value per device. Mm-hmm. You'd think you know exactly where that is and what it's doing, but that sounds like it's not the case.
Yeah, I think 2 reasons come to mind. One is that security teams historically have not been asked to protect the OT environment, right? And in fact, there was a time when we were only protecting like the devices that are in the office. So that's one, right? The OT security is a new mandate for us. Number two is the deployment of these devices are often done at the behest of the business, and they're being done by like technicians, like I mentioned before, who walk in, deploy the device, push a button, okay, that looks like it's working, and they go on to the next job. And oftentimes that's not done with security's awareness. Right? So you have the situation where devices are potentially changing. Not as bad as like in the cloud where people are spinning up EC2 instances left and right and not telling anybody. So I wouldn't call it like shadow OT or anything, but it's often done without security awareness. And so that would be the second reason why I'd say.
I think I want to use that to loop back around to one of the earlier questions or topics I touched on was how the heck could a security team even, or just a practitioner, start to understand some of the concepts, some of the hardware, some of the protocols in here? Are there good resources for them on any of those that range of topics?
Yeah, I'd say there's definitely more and more talks and presentations on that topic. CISA also has a lot of information on OT and ICS as well. I've seen a few Udemy classes as well and things like this. And there are also trade organizations around OT, and they're definitely talking more and more about OT security as well.
Interesting. Can you give us a sense of, are those discussions, is there something that's particularly OT about them, or do they sound more like kind of a normal, like a DevSecOps conversation, an Appsec conversation, meaning we're threat modeling, we're worried about input validation, or we're worried about, buffer sizes or things like that. I'm just kind of curious if there are also interesting threat models or design considerations that are perhaps unique or different when they come up in OT conversations.
They are unique in the sense that they're tackling a different mindset, but I wouldn't say those conversations are at the level of maturity of the examples that you mentioned. It's definitely like back to basics and let's get started from
now. Huxley, in that list, you mentioned a couple presentations, online resources, online courses. You've done a couple presentations as well as I was reading your bio. Organizing BSidesNYC. I'm curious, to touch on kind of conferences for real quickly. What would be the good type of abstract you'd love to see come through on an OT topic?
Yeah, so for the last BSides New York City, we had 21 speaking slots and like over 100. I don't remember. Like the acceptance rate was like 15%. So like we had like a lot of submissions, and your questions, I don't know, might imply that there's something more sophisticated, but really the good abstracts are just the ones where people simply like put in the effort. For example, I had this one abstract where they really didn't seem to do a whole lot. Like the abstract was just like super cryptic. Basically it was like, okay, point one was even bots face security threats. And then point two was bots have to run somewhere. And point three was good implementation practice are not standardized. This person basically put the CFP selection committee in the position of having to guess what they were even talking about, right? So put in the effort, make sure your abstract is clear, and we understand what the important point was. Which I know it's like not a great answer to your question, but basically just says, hey, listen, put in the effort. If maybe show the abstract to a friend. Hey, like, do you know what I mean here? Because if that person's having to guess what you meant and why anybody should care, then already that's going to be a miss. So I like that
part, how you put in, like, why should I care? Either as the reader or if projecting, I'm going to be the person on the listening to this presentation. That seems like answering that question well seems pretty important.
Yeah, I mean, if you want to go advanced, then yes, like you want to pick a topic that's timely and so on and so forth. But like, come on, just do the basics first, right? abstract 101, make sure it's clear and make sure people understand why you think it's important. Because if you can't explain to me why you think it's important, then I definitely can't tell why you think why I.
So maybe pulling all the pieces we've been talking about here is, what are some things you think are timely right now for in the realm of OT? Whether it's we talked about a little bit about CISA, we talked about a lot of things. What would be a few things that are timely for you that you look forward to reading more about, researching more about, even presenting on?
So I'd say on the OT side, understanding new devices as they're coming out, how they have security in mind and things like this. Also, perhaps some sort of more substantive way to bring security to OT, right? These OT environments tend to be very large. That tend to be a lot of different devices. How do you bring security to that entire environment at scale, right? Some of them are geographically dispersed. How do you bring security to all those different sites at scale? That's a hugely important problem to try and solve. I mean, some of these places have 20,000 of these little devices all over the place, all headless. Right? What do you do about that?
That's a lot of USB sticks to go carry around and to plug into things.
Yeah, absolutely. If they're not remotely managed. So I'm sure somebody is going to do something with AI and OT security at some point. I guess that's super timely as well. But I don't know, man. I haven't jumped on the large language model bandwagon yet, so I'm a little cautious.
Some VCs will be calling you up right after this interview. No problem.
God, yeah. Please,
Huxley, now you said, not remotely managed sounds like a tough way to not scale things, but it's 3 words about that just kind of describes the OT situation. One of the things we like to do is ask our guests to describe AppSec in 3 words. And I'm curious whether it is looking at this angle of OT or elsewhere, what comes to mind for you in 3 words about AppSec?
Sure. Yeah. 3 words that come to mind for AppSec are, this is going to be bad grammar. Well, it's 3 words, so I gotta. Anyway, it's cheaper than alternatives.
Interesting.
AppSec is cheaper than alternatives.
I like it.
Because if all of our applications were developed with SDLC in mind and properly tested before they're released, then there's a lot less work to do in other parts of defense.
There are some CISOs out there, I think, right now applauding you and very thankful for that message. Yeah, I like that one.
And it's cheaper. The developer time for well-developed secure software is cheaper than all those network controls, host-based controls, data protection controls, and so on and so forth. It boggles the mind how much money you have to spend to basically protect and work around.
Absolutely. Now, speaking of alternatives, Huxley, hopefully everyone has been enjoying this conversation, but if they want to hear more from you or see you talking about these topics as well, where else can they find you?
Yes. So my next talk is going to be in New York, my hometown, at the, hold on, this is a mouthful. So let me look it up. Okay. The New York Metro Joint Cyber Security Coalition Conference and Workshop. All right. So that's going to be on Thursday, October 19th. And I'm also scheduled to be at BSides Calgary in November.
Very fun. More BSides. Calgary, stay warm.
I'll try.
And also, I want to say thank you for joining us, Huxley. This has been fun. A little bit tripping into the past of these devices, but hopefully you've given us some hope for the future as well. And so that we'll have you back on maybe 30 years from now just to see what, if anything, changed.
I hope sooner than that.
Thanks again, Huxley. Thanks as well to John. We'll also hope to see you sooner than 30 years from now. Thank you, everyone else. We're going to take a quick break and return with news of the week.